Hi, this is Engineer Spock from engineerspock.com, and I'm glad to see you here in this class. This course is dedicated to one of the most interesting, peculiar, fraught with peril, and astonishing things in the world, to problems of working with dates and times. A lot of facts related to dates and times are so interesting that learning those facts, you just say, "Wow, hell! Who could ever imagine such strangeness?" Almost all the software works with date and time in one form or another. Some programs, of course, need to work with date and time more than others. However, date and time hide many pitfalls even in straightforward scenarios. We all know that security and logging are regular aspects of almost any program. There is a clever phrase that sounds like, "Developers recall about security when it's too late." The same can be said about date and time. Most developers don't even imagine how many bugs are hiding behind the simple face of date and time. Those bugs are sitting in programs and waiting for their moment to blow up your production code, causing very adverse repercussions. That's why working with date and time is the full-fledged and critical aspect of software development. Have you watched magnificent, enlightening TV shows by BBC? This course in some parts is like those BBC shows because you'll learn many interesting, surprising facts. Besides being familiar with peculiarities of working with date and time, you can write much more reliable and maintainable applications. This course is aimed at all kinds of developers. It provides solid theoretical base reinforced by tons of practical material. In short, the course covers the following topics: date and time fundamentals, including Gregorian calendar, UTC, GMT, atomic time, how computers store time, NTP, date and time formats based on standards and specifications, Epoch time and Unix time, date and time scope and perspective, time zones, including definition, the complex one, daylight saving time, or DST in short, providers such as IANA or TZDB and Microsoft, date and time in .NET. We will look at the following types: datetime, datetime offset, time zone info, time span, different calendars, stopwatch, and many intrinsic details. Node time, including the overview, the core types, and unit testing. A great number of best practices of working with date and time. Arithmetic on dates, parsing, calculating of birthdays, scheduling events, date formats, ranges, and other. In other words, an exciting journey is waiting for you. Just take it, relax, and enjoy. To understand the best practices of working with date and time, you at first should have a good understanding of the problems related to timekeeping, without taking into account any particular programming platforms. That's why we will start from the theoretical fundamentals. Besides, theory related to date and time is fascinating. As I said in the outline, dates and times are not so easy as you could think of them. The main reason why we don't think and know so little about dates and times is that dates and times are everywhere. They surround us. Clocks are everywhere. Calendars are everywhere. On the wall, on your hand, on your phone. We can't schedule anything without relying on dates and times. Dates and times are fraught with peril, and we stumble upon those perils from time to time. Sometimes we fall into the trap because of our ignorance regarding dates and times fundamentals, or just because of hidden pitfalls in the frameworks or libraries themselves. Why is it so important to know how to manage dates and times properly? Here are the main two reasons. First of all, There were a significant number of bugs related to dates and times throughout the history of programming. And the second and the most important one is that sage people and wizards say that one who knows everything about dates and times can become a dark lord of time, ruling all the world. That was a joke, actually. Here are just several examples of lost revenues caused by dates and times related bugs. At the end of 1996, the smelting furnaces of a New Zealand manufacturer suddenly stopped working, what was caused by incorrect processing of the 366th day in that leap year. MP3 player Zune made by Microsoft in the New Year's Eve in 2008 hanged up. That happened massively. All the users of Zune have faced that bug. That was a bug in the firmware of a clock chip. There was an infinite loop caused by incorrect if statement related to dates comparing. The software error of an MIM-104 Patriot, a surface-to-air missile or SAM system, caused its system clock to drift by 1/3 of a second over a period of 100 hours, resulting in failure to locate and intercept an incoming missile. The Iraqi missile impacted in a military compound in Tehran, Saudi Arabia. That happened on 25th of February in 1991, killing 28 Americans. A colleague of mine and I introduced a bug related to the absence of the February 29th in the non-leap years. We didn't consider that fact, and even our unit test didn't cover that case, and as a result, an invalid data was passed to a bank terminal, which declined it and declined an entire transaction. That resulted in a situation when customers couldn't buy tickets by their credit cards. The whole day all the bank terminals refused to accept transactions. Long story short, if you don't pay close attention to how you process dates and times in your programs, you'll see the circus. So, to avoid problems in the future, you'll learn all the nitty-gritty things related to dates and times. Time is the fourth dimension, along with 3 spatial dimensions. The universe doesn't care about time, so human beings were those who invented clocks and calendars to measure time. How we measure time depends on humans entirely. There is a significant problem with human beings. Have you ever heard something that is called a human factor? Yes, that's right, we're unstable, with hard-to-predict behavior. Human factor causes many problems. For example, people tend to think about time locally. Unfortunately, it's not always correct to think about time in the local perspective. I'm writing these words in the morning, but it doesn't mean that it's morning everywhere on the planet. It sounds like I'm saying obvious things, but believe me, we tend to forget about everything, including such obvious things, when programming. Programmers very often just blindly call daytime now and pass the result to the user. It doesn't work well in many scenarios. So, to determine what time is it, we at first should know whose time we want to determine. Where does it last? So, such terms like today, tomorrow, yesterday, and names of days like Monday, Tuesday, or specific days like January 1st, and so on, all these notions have a local perspective. It means that Monday for one person is Tuesday for another one. Today for one person is tomorrow for another one. People like to change rules. A very long time, people measured time by using the Julius calendar. It is called Julius because Julius Caesar introduced it. There was a problem with that calendar system. It accumulated one excessive day every 128 years. That happened because the length of a year in Julian calendar was 365 and quarter of the day, what is greater on 11 minutes than the length of a tropical year, also known as a solar year. Pope Gregory VIII introduced another calendar which fixed that problem of accumulating one excessive day every 128 years. Gregorian calendar was introduced in 1582 on October 4th. The Gregorian calendar had to eliminate all the accumulated excessive days immediately. So after the 4th of October in 1582, the 15th of October goes. Can you imagine something like this in modern days? 10 days are just gone. There is no the 5th of October in 1582. According to the Gregorian calendar, days from the 5th to 14th of October inclusively just don't exist. Do you know what is more funny? There are more than 40 calendars we're aware of. Armenian calendar, Aztec calendar, Byzantine calendar, Indian national calendar, Hebrew or Jewish calendar, Masonic calendar, Chinese calendar, Islamic calendar, and many others. The majority of them have forgotten long ago, but at least 5 calendars are active and many people measure time relying on them. Here are they. Of course, the Gregorian calendar, Islamic calendar, Hebrew calendar, Chinese calendar, and Indian national calendar. I'm actually sure some other calendars are still alive. By the way, taking into account that the 5th of October in 1582 doesn't exist, how do you think what will happen if we write the following code in C# using standard BCL library? If you thought that there would be an exception, you are wrong. Nothing bad will happen. That date will be created successfully. Why is this so, one might ask? And the answer is quite simple. The default calendar behind the date-time structure is the Gregorian calendar, and the Gregorian calendar is the so-called prolaptic calendar. Prolaptic means that we pretend like the Gregorian calendar was always in effect, so all dates are still there and they are all valid. As I already said, not all the problems are related to human beings. Some of the problems are caused by the universe itself. Even children know that there are 60 seconds in a minute, so if you are a smart guy, answer the following question. How do you think? Is it possible that 1 minute can last 61 seconds? If yes, why? I say no, it's impossible. But what do you think? And here is the answer. Have you heard about leap or so-called coordination seconds? The thing is that the rotation speed of Earth is not constant. It slows down a little bit, and from time to time we need to introduce that leap seconds. Sometimes we introduce them once in a year, sometimes once in a couple of years. Why is this important? The importance of such things depends on the case. For coordination of events in space, it might be very important to keep track of leap seconds, especially in high-frequency scenarios. Most people are not concerned about leap seconds and even have never heard of them. That's because no one cares of such timing precisions. But you, as a programmer, always have a chance to stumble upon problems related to time measurement, Everything depends on the type of software you are working on. For example, in 2016, December 31, at 59:59:59 p.m., the next tick will set the following time. In reality, the Universal Coordinated Time will just pretend that the last 59th second in the year lasts 2 seconds instead of 1. Do you think that no one cares about leap seconds? If you think so, then you are wrong. Your clocks on your PC take into account those leap seconds, since they are synchronized with UTC. The NTP stands for Network Time Protocol, is a protocol of time synchronization that makes PCs all around the world aware of leap seconds. Synchronization of clocks sometimes plays a very important role in people's lives. Here's an example. Did you know that a day on Mars lasts for 24 hours and 40 minutes? So, people who observes and controls the rover on Mars have to wake up 40 minutes later every day to keep their lives in sync with the life of that rover. This is because the rover has to operate at certain hours on Mars. Can you imagine how hard it is to live such lives? People eventually end up waking up at night. It is just plain craziness. Okay, in the next lecture you'll learn how a computer stores time and what precision it supports. A separate interesting topic is the problem of calculating the age of a person. It seems like calculating the age is a trivial thing. However, it's not as simple as it seems. If you Google for how to calculate the age of a person in C#, you'll find dozens of answers that provide the following function. You see that function on the slide. What this function does is that it subtracts the birthday from the current date and then divide the result on 365.242199. 2400th provides a correction for leap years. For most of cases, this function works fine, but it's not sufficient to have a function which doesn't work in certain cases. For example, according to this function, a human born on the 2nd of March 2007 in the non-leap year will be in age of 1 year on 2nd of March 2008, which is a leap year, while a human born on 2nd of March 2008, which is a leap year, will be in age of 0 years on 2nd of March in 2009, which is a non-leap year. Don't ask me why is this so. The short answer would be, it's just mathematics, nothing personal. Another problem with this function is that it relies on daytime now. We don't know whose birthday it is. Depending on the time zone, the difference in one day may easily occur. Let's look at the correct function. This method takes a birthday and the time zone for which we want to perform the calculation. At first, it converts the current time on UTC to the current date according to the requested time zone. After that, it calculates the difference in years, and if the birthday hasn't occurred yet in the current year, subtract 1 year. All is pretty simple and works correctly for any dates. However, there is still one corner case is hiding. The question is, which day should we treat as a birthday in non-leap years for persons who were born on 29th of February in a leap year? The thing is that in different countries, law defines this case differently. Some countries state in a law that the birthday should occur on 28th of February, while other countries state that it should occur on 1st of March. This function implies that in this corner case the birthday should occur on 28th of February. You might think that this is a bullshit. Who cares about such things? And you'd be wrong. This is a very important thing from the law point of view. Criminal code has to define a precise way of calculating a person's age, because it needs a way to determine the day when a person becomes criminally responsible. Here is the function which calculates the age, and in the corner case we discussed a second ago, it implies that the birthday should occur on the 1st of March. In this case we explicitly check the month and the day, so the birthday in that corner case will occur only on the next month, on the 1st of March. There is another quite exotic case. Don't laugh at it, though why not laugh if you want to. So here's the story. Assuming that a baby was born on 31st of December 2016, how many years will that baby be on 1st of January 2017? And here's the answer. It would be logical to answer that the baby will be 0 years old. However, in certain East Asian cultures, the baby would be 2 years old. How this is possible, you may ask? The thing is that in that cultures they start to count age from 1, not from 0, and they increment the number of years when a person crosses a new year, not on their birthdays. Sounds crazy? Yes, it does, and this is the world we live in. So if you write software for some Asian fortune teller, don't forget about such a peculiarity.